Morning. I'm Joseph Opati, math teacher in Boqol Sunna Academy. We continue with our math lesson. We have been covering the topic indices. Already we have had 2 sessions. Now the first 2 sessions I was able to cover what? The laws of indices. Then today we discuss about the application of those laws. So again, just to make sure we're comfortable, I'll just have some 2-3 minutes to remind you of the laws. But of course, to get the laws, you can try and watch the previous clips where I covered the laws and gave the, of course, application. But for now, I'll just quickly mention them, then we discuss what? Questions in terms of their various application. Then of course, I'll be able also to clear the last part of the topic, which will be index equations or exponential equations. So quickly, in terms of the laws, we had law number 1. This was the law in regard to what? Multiplication of numbers to similar bases. That was stated as what? X power n times x power m is equal to x to the power of what? N plus m. Then our second law, law number 2, was in regard to what? Multiplication of numbers, division of numbers to a similar base. The law was given as x power n divided by x power m. Of course, the outcome will be x power n minus m. Now, we went on to discuss our third law, which was the law in regard to what? Multiplication of numbers to the same power. Of course, that was what? The outcome. You multiply the bases, then whatever product you get, you let it do what? Assume that similar power. Then we went to the fourth law. If you remember very well, the law was what? In regard to division of numbers to the same power, where we had what? X power n divided by y power n, giving us x over y to the power of n. That was law number 4. Then we went to law number 5. Law number 5 was the law in regard to what? Raising an index to another power. That was x power n raised to power m. The outcome was you get x raised to the power of the product of n and m. That is what? nm. Then we went to law number 6. Law number 6 was the law which was in regard to what? The fraction index. That was nth root of x is equal to what? X power 1 over n. Where we said if at all the nth root is square root, that will be what? X power a half. If the nth root is cube root, you'll have what? X power a third. If the nth root is fourth root, what will you have? X power a quarter. So of course, I gave those examples on how to, of course, to apply it. So we go to what? Our law number 7. Of course, I'm just having a little recap of what we covered in the previous 2 lessons before we embark on now questions which now appear in most exams in terms of the mock exams and the main KCSE exam. So law number 7 was the law in regard to what? The zero index law. So x raised to power 0, what are you getting? You get 1. We said x in this case represents any number. It can be a fraction, a decimal, an integer, or even a surd. So any number raised to power 0, you get what? 1. Then we went to what? The law number 8. If you remember very well, law number 8 was the negative index law. So law number 8, this was what? We said x raised to power negative n is same as what? 1 over x power n, or x power n is same as what? 1 over x power negative n. But we said in most cases this is the part we apply, because we tend to do away with what? Negative. But once in a while we shall require that change from positive to what? Negative. Now that was law number 8. Then our last law, which we argued actually was derived from what? Law number 8. And of course we covered that in our previous lesson. So law number 9 was given by, let me just clear whatever we have here. Law number 9 was given by x over y power negative n, that will be y over x power positive n. So those are 9 laws. So today we'll have an easy time just applying those laws and of course making sure we enhance your understanding of those laws. Now questions. Just have some questions here. Question number 1. So question number 1. You are told to simplify. Simplify 8 to power 2/3. So how do you simplify 8 power 2/3? Of course, I gave the easy option. The easy option would be consider 8 and then write 8 in terms of what? In index form. In terms of the, of course, you choose an appropriate base. In this case, the appropriate base will be base 2. So you take 8 and you can factorize. 2 goes there, 4. 2 goes there, 2. 2 goes there, 1. It means 8 is what? In terms of base 2, 8 is what? 2 power 3. Then remember we had what? 2 power 3. Then multiply 2 over 3 by 3 to give you, of course, 2 over 3 by 3. What do you get? You get 2. This means I'll have what? 2 power 2, which in the end will be what? Will be 4. That becomes the final answer. So the approach begin by expressing what? 8 in index form, of course choosing what? The most appropriate base. In this case the base is what? 2. That is question 1. We go to question number 2. Question number 2 would be this. Of course it's a bit tricky compared to the first question I've given. Question number 2, you are told to simplify. Question 2. Simplify. We have 8 power 2/3. 8 raised to power 2 over 3 plus 4 raised to the power of 3 over 2 over 16 raised over 16 raised to the power of negative 3 over 4. So we have negative 3 over 4. Now remember, we are having a plus here. We don't have an index law in regard to what? Addition. Are we together? So what do? The only approach here will be you work out that separately, work out that, then later combine. Of course, by adding the outcome from that workout and that workout, and then dividing what? By the workout of that. So where do we begin from? We begin from that portion. We have 8 power of 2 over 3. So we said in this case the 8 expressed in terms of, in index form would give us what? 2 power 3. Then recall we had what? Our 2 power 3 there. Multiply 2 over 3 by 3. If you're very keen, what do you get? You get 2 power 2, whose eventual outcome is what? Is 4. Then we come to our second part. We have 4 raised to power 3 over 2. Again, express 4 in index form. Of course, in this case, the appropriate base will be base 2. That will give us what? 2 power 2, which is same as 4. Then raised to power what? 3 over 2. So take 3 over 2 times 2. That gives you what? 3. You end up with what? 2 power 3, which will be what? Which will be 8. So this is the outcome from that workout, the outcome from this workout, of course, of this. Then now we go to our last part. We have what? 16 raised to power negative 3 over 4. So how do you approach this? So I'm going to change 16 and have it in index form. So 16 would be, of course, 2 to power 4 raised to power negative 3 over 4. Multiply negative 3 over 4 times 4. Of course, in accordance with what? That was about the fifth law that I gave you. So this by this will give you what? 2 power negative 3, which is same as what? 1 over 2 power 3. In the end, you have 1 over 8. Then now you combine. So this one here, the numerical value of that is 4. So you have what? 4 plus numerical value of this is what? 8. And then this line means what? There is division. Then the outcome of this is what? 1 over 8. So we continue. This gives you what? 12 times reciprocal of that. What do you end up with? You end up with 96 as the eventual value of that. So we are done. What was the advice? We are saying we don't have what? A law in regard to addition. So our law is in regard to what? Division and multiplication. And of course, there are lots we discuss. So we don't have a law that requires us to do what? Apply in case we have what? Addition. So what do? Work out this separately to obtain that. Work out this separately to obtain that. Work out this separately to obtain that. Then of course you do what? You combine. Take the outcome of this plus outcome of that, divide by the outcome of that. That becomes the eventual answer. So in that regard, I'll give you some 2 questions for your homework which you can attempt, and then we can go to something else. That was question number 2. Okay. So question number 2, homework for you. Can just say homework here. Question is simplify the following. So I'll give 2 or 3 questions. The first is this. We have 27 raised to power 2 over 3 plus 1 over 81 to the power of negative 3 over 4. Number 2, we have 27 raised to power a third times, let me make this one to be clear, that is what? A plus. This one is what? Multiplication. We have 81 over 16 raised to the power of negative 1 over 4. So you can be able to attempt those questions in line with the example I've been able to give. Now we go to discuss 2 more questions which maybe I consider them to be tricky. Then we can go to our last part. So are we done with copying this? Good. So we continue. So next question is this. It's a tricky question. You can just be able to do it. You are told simplify. This should be our question 3. Question is simplify 20 power 2n times 100 power 2 minus n divided by 64 power n over 3 over 20. This is a question which appeared in one of the past Nairobi mock exam. It's a question which will be able to test, of course, your understanding of those basic laws we have covered. So let's see how we handle the question. So we are saying, I'll begin by, first of all, maintaining that the way it is. Then here, 100 in terms of index, in index form, is same as what? 2 to the power of 2. Then I remember I have what? The power 2 minus 9, which must be maintained there. 10 power 2 has only been able to replace the 100. Divide by 64 in terms of base 2 will be same as what? Of course, let me have it here. Divide by 2 power 6, of course, into n over 3. Then over 20. Then we continue. This will give us what? 20 power 2n times 10 power 4 minus 2n. So we open the brackets here. 2 times 2 will give you 4. 2 times that n will give you 2n. But we have what? A minus which you must be able to consider. Then divide by n over 3 times 6 will give you, of course, 2n. Because 3 goes here 1, 3 goes there 2. So we have 2 power 2n over, you maintain your 20 there. Then, what will be the next step? Next step, I hope I can be able to do it from here. We have 20 power 2n, so 20 power 2n times, now we are having a subtraction in the index, meaning previously we were doing what? Dividing numbers to the what? The same base. So I'll have 10 power 4 divide by, of course, 10 power 2n. So because of minus, it means what? We are doing what? Dividing numbers to the same base, and the base involved is what? 10. Then divide by 2 power 2n. Now we continue. We'll have that over what? Over 20. Now from here, how do we proceed? This is how we proceed. I will have the 20 power 2n maintained there times 10 power 4 over 10 power 2n times reciprocal of what I had there initially, that is what? 2 power 2n, of course, over 20. Then allow me to wrap that to create more space for that workout. So we proceed. How do we proceed? We shall have 20 power 2n, 20 power 2n times 10 power 4. Then we are having to multiply this and that to give us what? 10 power 4. I multiply this and this. Keep in mind, we have what? The same power in the name of 2n. We said when you're multiplying and the powers are the same, what do? Multiply the bases to give you what? 20, and let that product assume what? That similar power 2n, of course, over the 20 we had here. If you're very keen, we have what? Common terms. They're going to cancel out. So what are we left with? We are left with 10 power 4 over 20. Of course, 10 power 4 is same as what? Is same as 10,000 divided by 20. Overall answer gives you what? Gives you 500. So we are done with that part. Let me try and quickly cover what? The last part of this topic. The last part is called what? Index equations. So I've been able to cover what? Laws of indices. We have so far covered how many laws? 9 laws. Now I've been able to cover what? Some question which now has been able to enhance our understanding of what? The different laws of indices we covered in the previous 2 lessons. Now the last part would be the index equations. Index equations, where I'm going to cover different, of course, forms of the equations. So we have what? Index equations. So index equations, quickly, let me go through them. So I'll be giving questions which come in different unique ways. Number 1, this is the first example. Let's have what? Example 1 under index equations, you're told solve for x. Solve for x. In the equation 3 power x is equal to 81. 3 power x is equal to 81. So how do you solve this equation? First of all, make sure you have what? Express 81 in index form. So that now we have what? Similar bases on both sides of the equation. I will have 3 power x is equal to what? 3 power 4. Now, we are saying this and that are equal. Now, the base are the same. Now, logically, and the obvious argument will be, if at all this and that should be equal, x should be something which is what? Same as whatever we have there. So x should be obviously 4. If at all x is anything apart from 4, this equation will not hold. So this is the argument we use. Whenever we have index equations and the base are similar, what do? You equate the powers. So we say in this case, x is equal to what? X is equal to 4. That was example 1. So I'm insisting, given such an index equation where we have what? Similar bases, what do? Equate what? The powers. We go to example number 2. So we have solve for x. Solve for x. Let's see what we have here. We are having an equation where we have what? X power 3 is equal to what? Is equal to 8. In this case, what will I have? I will express x in 8 in index form. Of course, 2 being the appropriate base. I will have 8 giving me 2 power 3. So in the previous example, the argument was having similar bases. You get what? The powers. Now here, the argument will be, whenever you have similar powers, what do? Equate the bases. Therefore, x is equal to what? X is equal to 2. So whenever you have similar powers, what do? Equate bases. You have similar bases, equate what? The powers. Now, we go to example number 3. Example number 3, again, solve for what? Solve for x. So, you are given the equation that 2 power x is equal to 1. Now, at this level, you remember the 0 index law. Whenever we have this 2 power, of course, a number, you get 1. Obviously, the number should be 0 because we said any number raised to power 0 gives you what? 1. So you just say, therefore, x is equal to what? 0. So again, we have seen the third form of that index equation. We quickly try to exhaust other equations. We have example number 4. Again, solve for x. And this time, this is the equation. We have 2 power x is equal to 1 over 8. So here, what do? First of all, I will have 2 power x being equal to 1 over 2 power 3. Then, recalling the negative index law, we are saying 2 power x will be same as what? 2 power negative 3. Having similar bases, what do? Equate the powers, meaning eventually x will be what? Negative 3. So we can go to example 5. So remember, to do what? recall the laws. We are seeing different laws, of course, now are being applied even in the index equations part. So we go to example number 5. You are given this equation, solve for x, and the equation is this. Solve for x, given that 5 power x is equal to 3 power x. So here we have two arguments we can use. Method 1, or the first argument, I will just say x is equal to 0, because if I have x as 0 here, what will I get? 5 power 0 will give me 1. 3 power 0 will also give me 1. Now, if you have any other power which is not 0, this equation will never hold. For example, let me assume x is 1. If x is 1, what will I have? 5 is equal to 3. Of course, 5 is not equal to 3. Therefore, 1 is not what? Solution for, of course, x. Now, what about if I choose x as 2? I'll have what? 5 squared is equal to what? 3 squared, meaning 25 is equal to 9. And 25 for sure is not equal to what? 9. Therefore, the only value of x which can make this equation to hold is power 0. 5 power 0 gives you what? 1. And of course, 3 power 0 also gives you 1. That is method 1. So whenever you're given such an equation where the powers are similar, and of course the unknown now is in the power, what do? Just take the power, equate the power to what? 0. But now, this would be a good approach in terms of the application of the laws of indices. So we have 5 power x is equal to what? 3 power x. So what do? Divide both sides by either 5 power x or 3 power x. So let me divide both sides by what? 5 power x. Now what will I get? 5 power x, 5 power x. Now having the same element in the numerator and denominator, what do you get? You get 1. What about here? I am dividing numbers to a similar power. I recall what? The law of division having what? The same power. That will give us what? 3 over 5 to power what? X. Then, how do you proceed? This is how you proceed. We are saying now, choosing 3 over 5 as, looking at 3 over 5 as our base. I want to express 1 in terms of base 3 over 5. 1 will be what? Will be 3 over 5 power 0, of course, equals to 3 over 5 power x. Now, having achieved this scenario where I have what? Similar bases on both sides, what do? You equate the powers. Therefore, x is what? X is 0. So we are done with that. We go to example number 6. If you note very carefully, the moment you have mastered your laws of indices, even the equations becomes easy to solve. But in case you forget now, you struggle. So we go to example number 6. Example number 6, this is the question. Solve for x. Solve for x. And this is the equation. 2 power 2x minus 1 is equal to 5 power 2x minus 1. So what do here? I've given you the two approaches. The first approach will be, first of all, divide both sides by either this or that. Let me choose to divide both sides by what? 5 power 2x minus 1 by 5 power 2x minus 1. So, having the same power, I'll apply what? The law of division having what? The same power. This would give me what? Would give me 2 over 5 power 2x minus 1. Now, this and this will give me obviously 1. Then I express 1 in terms of base 2 over 5. Now what will I have here? I have 2 over 5 power that being equal to 2 over 5 power 0, which has the same numerical value as 1. Having the same basis, what do? Equate the powers. Therefore, 2x is equal to 1, and eventually, x is equal to what? A half. And of course, we said method 2 will be the simplest approach. We said whenever we have the powers being similar, and that's where the unknown is, what do? You just take what? The power and equate it to what? 0. So 2x will be 1, meaning x will be what? A half. So we are done with that question, and now we want to go to more complex, of course, questions. So we proceed to example number 7. Example number 7. This is the question. So I want to change the question now here. Example number 7. Example number 7. We have 3 power t. Solve 3 power t plus 2 times 3 power t is equal to what? 243. Okay, this will be the first approach. We can apply the concept of factorization taught in algebra. So method 1, I'm going to apply that. If you're very keen, this and that are similar. So I'm going to factor 3 power t out. Now, when you have something like this, let's say x plus, let's say 2xy, and you're told to factorize. Now, what's a common factor here? X. So we'll have x into 1. Why have I put 1 there? Because x times 1 will give you that x. What about here? I will have what? 2y. So whatever I've done there is whatever I will do here. So in this case, we had what? X being the common, of course, factor. Here we have what? 3 power t being common. So 3 power t has been factored out. I'm left with 1 because this times that will give me what I had there initially. Plus this has gone out. I'm left with what? 2 is equal to what? 243. Then what do? You add 1 and 2 to give you 3. So you say 3 power t into 3 is equal to what? 243. So I'm saying this is the what? The first approach in terms of how we can handle this question. Now, the presence of brackets means what? We have some multiplication somewhere here. So I want to obtain what? 3t. So an expression for 3t. I divide through by what? 3. So that and that will cancel. I'll be left with what? 3 power t. Then 243 divided by 3. If you are keen, what do you get? You get 81. So equate what? 3 power t to 81. Then express 81 in terms of base 3. That will be 3 power 4. Having the same powers, we do what? Equate having the same basis, we equate what? The powers. In the end, what is the value of t? T is 4. That is the first approach, which maybe will be okay with somebody who's okay with what? Concept of algebra, that is the what? Concept of factorization. Now what about our second approach, which I think would be the most easy to remember, and of course they're commonly used by many students, they prefer it. Approach number 2 would be this. Given that index equation, how would you get t? We are saying, we note that we have what? 3 power t here and 3 power t there. They are similar. So introduce another unknown, of course, to replace what? The 3 power t. I can say let 3 power t be y. So in that equation where I have 3 power t, I do what? I put y. So what do we have there? Y plus 2 times y, which is what? The 3 power t is equal to 243. Then what do I get? Y plus 2y is equal to 243. Y plus 2y gives you what? 3y is equal to 243. Then divide through by what? By 3. By 3. Y will give you 81. Now, once you solve for y, don't get too excited and stop there. Remember, y is our own introduction. Initially, the question wanted what? The value of t. So how do you get y? Go back to your equation connecting y and t. We are saying 3 power t is equal to y. But now we have what? The value of y as 81. So you say 3 power t is equal to 81. 3 power t will give you 3 power 4. In the end, t is equal to what? T is given by 4. So that is the second approach to our question. So I just want to make sure at least exhaust every possible area. So our last question, then I think we shall be done. So example number 8. Example number 8. This is the question. Solve 4 x and y. Of course, the equation is 4 power x times 3 power y is equal to let me have 24. So you find this a unique type of equation where you have what? 2 unknowns in a single equation. So what do? Just remember what? We are dealing with what? Indices. Try as much as possible and express these numbers in the, of course, index form, but now using what? Appropriate base. Here, 4 can be what? Expressed as 2 power 2. So I will have 2 power 2, but remember you have what? X. 3 is okay. No alteration in 3 power y. Then 24 broken down into 8 times 3. Then in our next step, what do you have? 2 power 2x times 3 power y equals to 8 is same as what? 2 power 3 times 3 power 1. Then equate numbers having what? Of course, on both sides having similar bases. So to get x, I equate this to that. So what do you have? 2 power 2x is equal to what? 2 power 3. Therefore, 2x is 3 and x will be what? 3 over 2, which is 1.5. So equate this to this. Why? They have similar bases. Next, equate this to that. So 3 power y is equal to what? 3 power 1. Meaning obviously y will be what? Y will be 1. So x is 1.5 and y is 1. So our last example in that regard, then of course I'm hoping you've gotten the concept in terms of the laws and of course how to solve the equations. Then get more questions from your various books including Made Familiar just to be okay with that. So our last example number 9. Example number 9. This is the question. You are told to solve for x, y, and z. So here we have what? 3 unknowns in one equation. This is the question. We have what? 2 power x times 3 power y over 5 power z is equal to, let's have 60. So how do you approach this? We are saying a similar approach to the question you have done previously. So I will have this one modified to what? 2 power x times 3 power 1. Of course, we have what? Divide by what? 5. Or let me make it simpler. Just say times what? 1 over 5 power z. Then 60 broken down into 4 times 15. Now, 4 times 15. 15 is what? 3 times 5. Our next step, what do we have? We shall have 2 to power x times 3 to the power of y times 1 over 5 power z equals to 4 is same as what? 2 power 2, 3 power 1, then times 5 power 1. If you are keen, how do we get our x? We equate what? 2 power x to what? 2 power 2. Therefore, our x will be 2. How do we get our y? You equate this to that. 3 power y to what? 3 power 1. Therefore, y is 1. How do you get z? Of course, equate 1 over 5 power z to 5 power 1. Now, the 5 power z will be same as what? 5 power negative z. Applying the negative index law, of course, equals to 5 power 1. In the end, what do? Equate negative z to 1. This means that z is what? Negative 1. So I think by that I have exhausted all the possible areas in terms of what? The laws and solving equations in terms of what? Indices. So that marks the end of our lesson.